waiting for a connection. Looks like we've got a connection. This might actually work. Okay. Do that. Do that. And next, in order to make an audio change, I'm going to turn off a fan. It's almost impossible to figure out the optimal temperature. The optimal temperature is difficult to achieve for some strange reason. I think it's airflow that's the real problem. These Grolsch beer bottles are fantastic because they got the little pop top there at the top. Rinse them out, wash them out. They make great water bottles, you know. Completely recyclable too. Alrighty then. So I noticed the Linux Foundation there has published their annual report in the last 6, 8, 10 hours, something like that. I'm probably not going to be glancing at that too much. It's just that, well, let's see. A number of little things going on. There was a FreeBSD Unix machine in my life where I was getting a panic over and over and over again, a panic. And I think it's hardware, not software, whatever the case may be. And the machine seemed to run fine with a couple ZFS ZPools, which were mirrors, until I went to add another disk. And I would add in like a brand new, right out of the package, Samsung SSD, and boom, the machine would panic and just come right down. When that happens over and over and over again, you end up with a messed up machine. Well, you end up with, well, you don't have to worry too much about ZFS, because ZFS basically guarantees that you have on-disk data consistency and integrity at all times. Your real concern is data which is in flight is going to be in memory cache, and it's not going to make its way to the disk. The other issue is that I think because of exactly that kind of circumstance, databases based on things like SQLite, they get scuppered. They get screwed up. Anyway, I decided the right thing to do was to find a way to recover those ZFS ZPools. It took a lot of work. I gotta let you know, it took me, I'm gonna say a good 16 hours of work to do the ZPool scrubs, migrate everything over to a totally different piece of hardware, you add back in the Samsung SSD into the pile, boot with a live DVD image of FreeBSD 13, create a new ZPool using the Samsung SSD. And I don't like calling it a ZPool. It's basically it's a single device, but it's brand new out of the package. I'm using it temporarily, so I'm not going to mirror. And then I did a ZFS send. And then, of course, in order to make this fast, I moved that Samsung SSD into a destination endpoint storage server, and then I do the ZFS receive, and I ended up with just a huge stack of snapshots coming over from a server that was called Europa. There it is, Europa. C0 was a pool, Z0 was a pool. So all of this stuff here, I'm listing ZFS file systems here with a number of characteristics, like what's the name of the file system, how much space is used, how much space is used by snapshots. I gotta let you know, USR Home has 75 gig worth of snapshots, right? There's a reason for that. Let me see. The rest is about compression, the fact that everything gets a SHA-512 hash checksum for every block of data into the ZPools. That's good. You want that level of data integrity. Ultimately, ZFS is a Merkle tree, which means you're going to have your hashes or your SHA-512 digital signature of every block of data is going to be referenced in another block. That gives you a data consistency path. And then there's a whole structure there with a thing called an Uber block at the top of the ZFS ZPool structure. And then all the blocks that follow that come later, you're tracking SHA-512 hash checksums of all the data that goes into the pool everywhere, as well as the fact that it gets mirrored, you get redundancy, you get all kinds of good stuff. In any case, and compression, Z standard compression, LZ4 compression, different ratios of compression. I find it interesting that this little test area right here has a factor of 6 compression. 32 gig of data. I don't even remember what I put in there. In any case, what was really interesting to me and of value to me to rescue this data was, just a second, I've got an alias here. This is an alias, ZL right there. And I realize the font is kind of small because there's a lot to show. But if I do a ZFS list straight up, okay, and say the type is all, recursive, I want to see everything, and just give me a line count. Just a line count. 2,400 file systems and snapshots. So there's a lot going on here. So, and I'm very happy. Snapshots are great. You can't go wrong with snapshots. Lots of snapshots. Hello there. So, just looking at, let's see, there's C0 OPTBW stuff. That was some software work. But right here, USR Home. So I went looking for basically the last snapshot in this file system here, which is off of the C0 pool, USR Home, users, right? Home directory stuff. What have I got for snapshots there? Well, that's easy to look at, no problem. We can do a ZFS list. I'm going to say again, type is all, recursive, and I'm going to specify that file system. Now that's an entire file system structure. There's like, the original pool, of course, and then there's a couple other different file system containers that I'm using. There's an entire structure here that had to be rebuilt. And let me just take a look at what's the final output here, and there it is. So the final output here is from 2021, December the 7th, right there, December the 7th. Now, is that what I'm looking for? Because I think if I go back further, I've got December the 5th. No, these two snapshots here I used in order to do ZFS send, ZFS receive type stuff. I think I want to go back further. Here's a 27. There's 27 meg of data. Let me take a look at this. Yeah, this right here. 2021, December the 5th. Okay. So ZL, give me the data in that file system. Blah, blah, blah. Let's go to USR home. Change directory into .zfs. Change directory into snapshot. Change directory into this snapshot right there. Let's take a look at the one I really want is Arch. That right there is a QEMU image of FreeBSD current, that's FreeBSD 14, on ARM64, and I was doing some experiments and I was doing some messing around work with it using QEMU. Anyway, when you've got a machine that panics and crashes and goes down, and you're running QEMU, and it's QEMU with multiple disk images, which are also a ZPool, a three-way mirror ZPool with a hot spare, you can end up with some real scuppered mess data. You really have to be concerned about what's the quality here. What's the quality? So there's a README snapshots right here in that directory because I'm careful. It's just that simple. I'm careful because I was doing work on FreeBSD 14 on ARM64. And it says right here, 6 hours later, more or less, like their system up and running, then crash with a kernel, panic, and a few days later, clean up the root file system. This is a clean snapshot of the ARM64 setup, so I've got a clean snapshot, and it says 6 hours later, more or less, we have some more ZFS file system set up, and I've got a timestamp right there. There's a timestamp from the original host machine. I'm on a destination backend storage system now. So that snapshot right there, that's really the one I'm looking for. So I don't want to be here. I want to go up, into that snapshot. Arch. There it is. That right there is clean data. Because I took a snapshot after I had established a three-way mirror ZPool hot spare, I had FreeBSD 14 booting, and I had built my own QEMU from the source code. So I'm going to want that. So I've managed to recover the ZPools from off of the original machine, managed to do a full ZFS send, ZFS receive, using what I call CAPR notation, CAPR. CAPR means capital R. That means full replication, everything that you ever wanted, everything you could think of. You get the backup of not just the data that's in the ZFS file system, but you also get all of the history of the changes in all the snapshots. So you get all your transactional data as well as all the metadata as well as et cetera, et cetera, et cetera. That's why there's 2,500 snapshots, because there's so many times when you want to like say, I've got a good result here, I'm very happy with where I am in this experiment, snapshot the machine, take note of the fact that you snapshot it after a quality result of an experiment, then you go forward from there. If you completely blow up everything afterwards, who cares? You've got snapshots, right? That's what ZFS is great for. So that kind of explains why I ended up with, this big complicated structure like this. All of this stuff here, coming up in green, is actually the original C0 and Z0 mirrored ZPool, fully freaking backed up replication, ZFS send, ZFS receive, and then I can dig in now and I can go back and get my original work. I don't want to lose the work that I did on the ARM64 system work. Okay. That took a lot of hours to do and a certain amount of talent. In any case, so there's that. Now, next, we've got, let's see, there's Esther. Esther's up and running, right there. There's Esther. Esther is a tiny little itty-bitty motherboard with a VIA Eden Esther processor on it. Okay. It's really a low power environment, really low power. And I simply screwed it right to the wall. There it is. So this is the console, which is a serial console, and this is the machine itself that I SSH into, and it runs and works just fine. It's a great little machine. And I think this is yeah, this is FreeBSD 14 right here. FreeBSD 14 for i386, 32-bit i386, and it works on a VIA Eden Ester processor. It's it's a funny little machine. And then we've got Phobos is another FreeBSD machine. I know people would be thinking, why is there all this talk about FreeBSD when the topic is supposed to be Linux kernel without a clue? We're getting there. This is an AMD 64. Typical run-of-the-mill 64-bit x86 FreeBSD 14 box. I was going to use this thing as the host for the ARM64 QEMU virtual machine instance. Maybe, depending. Then we get to this, Hydra. What am I doing with Hydra? Let's see, invalid group. I was just in the process of setting up a user account here. Uptime on this machine is 9.5 hours. I took a nap. Hydra is, it says Debian, but it's not. It says Debian, but it's not. It's actually a much nicer variation of Debian. It's much, much more friendly. It's wonderfully easy to work with. You get all of the goodness of Debian, and you get none of the garbage of Systemd. None of that trash. Systemd is just layers and layers and layers of obfuscation and interrelated dependencies of services and poor documentation. It's absolutely horrible. It's horrible what's happening in the Debian world with Systemd. So anyway, I said, screw it. I'm going to go over to Dev1, and it's wonderful. So this machine here, I don't think it's got much on it. I mean, I installed like a baseline desktop, so there's like some graphical packages. Actually, I think it's probably got, let's see, oh, it's got the basic XFCE stuff, but I don't really care right now because I'm running it. I'm just SSH into it. I'm going to use this, sort of local source. I was thinking of building the Linux kernel 5.15.6, or possibly an RC, a release candidate. I mean, just for fun, right? I mean, why not, right? I was thinking of doing that. But I don't know. I don't have any of the development stuff installed on this machine. I probably don't even have a compiler. No, there's no compiler, there's no debugger, there's like none of the stuff that you would need to build the Linux kernel. So that gets me around to finally, the Linux kernel without a clue, which means, what if hypothetically, right, you fell into building the Linux kernel, but you've got no idea how to even get started. I wonder if resize is in there. Oh, okay, we can do resize. Columns equals 80 by 43. That'll work. We'll just use a simple terminal kind of approach. Let me check my environment. I am root right now. Terminals VT100, very simple looking, just incredibly simple environment. Yeah. Okay, so the question becomes, I did install curl because curl is awesome. If you want to download something off the internet and you're working with the command line, you can't go wrong with curl. Curl is your friend. Curl makes life wonderful. And if you can't handle curl, then you can fall into something like wget, right? Whatever works for you. I use curl for almost everything. everything. It's wonderful. And libcurl, of course, for anything which development where you want to do, say, you know, key-based SSH communication between, you know, server to server type thing. And let's not even get into that. Okay. In any case, so Linux 5.16.6, maybe. I'm not sure. Let me go to yet another machine. Here's another machine. And this machine I was just messing around with is Enceladus is actually Debian on IBM Power, 64-bit IBM Power. That right there is a wonderfully stable machine, gets the job done. It rips through the entire Linux kernel pretty quickly, even with a huge number of modules. I mean, I think of it as an LS mod here. We got everything from soup to nuts. Pretty much, you know, the usual stuff you need. And if I look in /lib modules, modules, I've got multiple versions and builds of the Linux kernel. Right now I'm running, okay, 5.15.1. So 5.15.1 dash Gen Unix. Gen Unix is actually short for generic Unix, but the truth is Gen Unix is just my, well, first off, it's my domain. It's a tag that I stick on the end of a version to tell me straight up, oh, I built that. That's me. I built that. And I build these things over and over again. You can look at it, you know, September, November, October, November. And it's a big gap, you know, and here we are today in December. So, there's 5.15.1. 5.15.1 was November the 9th. I just downloaded 5.15.6, the source code. What's in lib modules over here? Just a second. Lib modules. Well, that's all you got. You got 5.10.0. That's what we're running. This is in, you know, x86 64-bit AMD Opteron type machine. It's nothing fancy. But let me take a look down lib modules. I just want to see how many files are down there. You know, we'll go to 5.10. That's all we got. Type is file. Give me a line count on that. 3,913. Wow. 3,913 kernel modules. Well, there might be some other accessory stuff down there, but 3,900 modules. This is everything from soup to nuts. I mean, it's everything. You can probably get drivers in there, drivers, kernel modules, whatever, for every damn device that you could throw a stick at. Everything from Diddle-eyed Joe to damned if I know. You know, it's just like hilarious. 3,913. That's ridiculous. And that's 5.10.09 AMD 64. Over here, I'm just curious. I gotta do the same thing. Find /lib modules. Different machine, of course. Oh, sorry about the flashing. I'll turn that off. Visual bell gone. Let me see. This is 5.10.0. Power PC. Sure. Well, there's 5.14. That's from Debian. That's actually from Debian. We'll do that. Type is if file -l. It won't be 3,900. Okay, 3,200. Again, pretty much everything you'd ever want. That's a big, fat, build. That's a big, fat build. Now, I try to, Linux is bloated, confirmed what again? Well, the Linux kernel has to support and deal with so much, just a wide variation of hardware out there, that you end up with modules like up the wazoo. Now, sure, I mean, we could do a minimal build, right? right? As minimal a build as possible, and say, you know, I only care about the stuff that I'm using. I do an LS mod over here. I'm only interested in the stuff that's actually used. Like if I see a 1 here, then I know that that kernel is currently being used. This one, this TG3 is a dependency, so used by. Okay, got it. All right, so this list of modules all the way down here, you really do need them. They're loaded right now. If I go back to the x86 machine and do an LS mod, yeah, everything, yeah, it's a lot of crap. A lot of crap. Soundwire, Intel. There's the AMD Radeon stuff. AMD Radeon. Let's see, AES, what? There's AES crypto support in the Intel hardware now, is there? I'm not aware of that. Anyway, yeah, okay, so Radeon ext4 file system type stuff. The ext4 file system type stuff, typically I build that right into the kernel. I don't even bother making that a module that gets loaded. That stuff I bake right into the kernel and don't even bother with making it a loadable module. There's my Realtek network driver. There's a lot of stuff here, you know. There's a lot of stuff here. SCSI module, SD, SCSI device module, lib ATA. Now SG, I can't remember, what's SG stand for again? Ugh. There's a lot of hardware. There is AES hardware instructions now in the Intel. Really? Oh, I was unaware. Huh. In any case, I was thinking of using both machines. I just wanted to fix something first because I had this code here that does Pollard row. And now Pollard row is a factorization or an integer factorization algorithm, well documented in the CLRS textbook, the CLRS algorithms textbook, which I've got, I don't know, somewhere handy. You can use it as a doorstop. You can also use it as a weapon. You know, if you really need to smack somebody really hard, it's a big book. It's got to be over 1,000 pages. Just a second here. I just got to see, do I have it handy or do I have it buried someplace I can't possibly get to? Oh yeah, it's buried. It's in a pile. You know, Algorithms, 3rd edition. Yeah. Algorithms 3rd edition. Anyway, it's in there. It's well documented, and that's Pollard row. It's easy enough to look up on Wikipedia. We can go over here and do this. Go Pollard row. Pollard row's algorithm for prime factorization. Yeah, there you go. There's Math World. Math World's got it covered. I think actually the Math World article is probably going to be a little bit better than the Wikipedia stuff. It's nice and concise, gets the job done. You're going to need your greatest common divisor algorithm using one of the oldest algorithms on the face of the planet Earth. Pollard row's algorithm in Wikipedia. I think they find new and interesting ways to make it. Yes, I'll give you money someday. This diagram looks like it comes right out of the CLRS book, and they give you some pseudocode. They give you some examples of how you do factorization using the Pollard row algorithm. Look, it's even got an animated image now. Well, it's been updated. Somebody updated this thing. And, oh, there's Fermat's number, F8, okay, F sub 8. 8th Fermat number. We can look that up. It's pretty darn simple. There you go. This is it's a little small. I know you can't see that. Here, let me just make that a little bit bigger. I couldn't see it. 2 to the power of 2 to the power of n. And then you add 1. So if n is 0, 2 to the power of 0 Well, anything to the power of 0 other than 0, you don't do 0 to the power of 0. I don't even want to talk about that. Let's just say any integer, I don't care. Actually, any non-zero number, including negative, I don't care, to the power of 0 is 1. Okie dokes. 2 to the power of 1, that's 2. 2 plus 1, 3. And there it is, 3. The very first, that's f sub 0, or Fermat's first number. F sub 1 is 5. So 2 to the power 2 to the power of 1. 2 to the power of 1, that's 2. To the power of 2, that's 2 squared, that's 4. 4 plus 1, 5. 17, we're going to get the same thing, except now we're dealing with 16 plus 1, because 16 is going to be 2 to the power of 4. So it's going to be 2 to the power of 2 to the power of 2. 2 to the power of 2, that's 4. 2 to the power of 4, that's 16, plus 1. 256 plus 1, 65,536, plus 1, right? You can see the sequence. In any case, the question is, where are the prime factors of these Fermat's numbers? Because it's 2, which is the smallest prime number. It's very similar to a Mersenne prime. It's very similar to a Mersenne prime. And I realize I'm getting a little off topic here, just in case anybody wants to look at, Mersenne primes. Not talking about the Mersenne twister, which I also can get into too, but the Mersenne prime, I hope I pronounced Mersenne correctly. Anyway, 2 to the power n minus 1. Okay? 2 to the power n minus 1. Okie dokes. Over here we got 2 to the power of 2 to the power n plus 1. What's with this offset of 1? Well, here's the deal. Every integer will break down into its prime factors. Every possible integer. So you take the number 27. The number 27 has, as its absolute smallest prime factor, 3. 3 times 3 times 3 equals 27. 3 cubed. So 3 has no factors. It's impossible to break down 3 into any other integer factors. So therefore 3 is prime. The only way you can express 3 as a product is 3 times 1. So any number, integer, that has the only factors that exist are itself and 1. That's a prime number. There's no other way to express it as a factor of 2 numbers or more, 2 or more numbers. So 27 is 3 times 3 times 3. Okay. All right. So the smallest prime number is 2. Unless you want to start talking about 1. Is 1 a prime number? Well, itself and 1. Is 1 a prime number? More beer has been spilled in pubs on the outside edges of universities over the past 1,000 years. Certainly in the last 100, when people get into arguments in number theory about whether or not, is 1 really a prime number? Because you can express it as itself and 1, but you still only have a single, and never mind, we're not going to get into that. We're not going to, okay. 0 to the power, I don't want to talk about that. Hold on. So 2 is the smallest prime number that if you stack it up like 3, I said 3 times 3 times 3 gives you 27. So you can express the number 27, which is a composite number, as the prime 3 multiplied by itself a few times. What about 3 times 5? Well, that's 15. Does 15 have any other factors? Nope. 3 times 5. Does 5 have any factors other than itself and 1? Nope. 5 is a prime number. So 3 times 5 gives you the composite number 15. So the idea on the table is, what if I take the absolute smallest prime number and I just stack it up as powers, like 2 times 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 2. Now, to the power of 8, that's 256. So, if you ask the question, is the number 256 a composite number? Well, it's divisible by 2 right away, so therefore it's a composite number. Furthermore, not only is it a composite number, but the only prime factor it has is 2. There's no other prime factors. It's just 2, 8 times. But there's nothing else. Okay. Add 1. Now you got 257. This is one of Fermat's numbers. The question is, what are the factors of 257? Off the top of my head, I don't know. Is that divisible by 3 or 9 or 6, 7, 8, 9, 9 plus 5, 14? Nope. Hold on a second. We're going to go ask a computer a silly question. We're going to factor 257. No, 257 is prime. It's a prime number. It has no factors other than itself and 1. Sweet! So a Fermat number, at least at the moment, that 257, is prime. We took a perfect power of 2 and then offset by 1. 17. Well, off the top of my head, I can tell you 17 is a prime number. What about 65,537? Factor. 65,537. That's prime. Oh. We got ourselves a sequence here. On the, this is the, online encyclopedia of integer sequences. Yep. It's a sequence number. There it is. We can actually go look, should we wish. There it is. The online encyclopedia of integer sequences. This has all been covered off by people in Numberphile and other YouTube channels that are big and famous and whatnot. It's simply an idea. Is there a likelihood that a Fermat number is a prime? 2 to the power of 2 to the power of n or k, whatever, plus 1. For any k greater than or equal to 0, is it a prime number? These numbers can get kind of big. If I use the basic simple calculator that's built into all Linux and Unix machines, you can do, let's see, 2 to the power of 2 to the power of k. Okay, so 2, so k, we already know 0, 1, 2, 3, 4, 5. I think 2 to the power of 5, that gives me 32, and 2 to the power of 32, that's going to be about 4 billion, right? It's about 4 billion, something like that. Let me just take a look at that number, and I'm going to add 1 to it. By the way, it's an RPN calculator. Sorry. Reverse Polish notation, RPN. You put the numbers into a stack, and then you perform operations on them. It's actually incredibly logical. It's wonderfully trivial to use RPN. Been using it ever since I had my first Hewlett-Packard calculator back in 1981, I think 1981 or 82 is when I had my first Hewlett-Packard calculator that did RPN, and I was thinking, this is great! Anyway, so there it is. It's about 4 billion plus 1. This will be Fermat number 5. Can we factor that? Factor that. Yes, we can. 641 multiplied by 6,700,417. It's not prime. It is not a prime number. But if you give somebody the number 4,294,967,297 and say, hey, can you factor that for me with pencil and paper? It's a little tough to do unless, you've really got time. Unless you've really got some time and you really have some mathematical skills and certainly some integer gymnastics built into you, let me tell you, that's not easy. But the absolute master of this, there is a man out there once upon a time, about 100 years ago, and he was looking at Mersenne primes, these guys right here. And, the question, of course, is, some of these have been known since antiquity. Since antiquity, I think there's a graph down here someplace that says, 1950, 1960, 1970, how we've been able to factor these numbers. I'm looking for a particular name that I should have carved in my brain, but I don't. I think it's Mersenne number 67. I think it's Mersenne 67, which was factored by hand at a mathematics conference about the year 1908. The name will come to me. It'll come to me in a bit. I should have it in the back of my mind because the guy's like absolutely incredible. The guy actually walked up to a chalkboard, and did it at a math conference. But he did the whole thing on a chalkboard without ever saying a single word. He simply stood up, said M67, and wrote it on the board. And then he wrote these two huge numbers, and then he did the multiplication right on the chalkboard. Up until that point, nobody knew whether or not Mersenne number 67 can be factorized. Nobody knew, because the algorithms required to factor large composite numbers can get really complicated. We start getting into things like the generalized number field sieve, and we start getting into things like, Pollard row is actually pretty trivial, which is why I said, there's F8 right there. I might actually be the person who updated this page, but, F8 is a good test number. It's a good test number. Why don't we calculate F8 right now? So exactly the same thing. I just, instead of doing a 5, I'll do a 6. We'll do a 6 here. Copy and paste. Boom. So there's Fermat's 6th number is this guy. Can we factor that? Let's see. Yes, that's a composite number. It's amazing how fast. Right? Yeah, the generalized number field sieve is also trivial, assuming you have a master's of science in number theory or perhaps a PhD doctoral degree, in number theory, in mathematics, and, and the rest of this is trivial. And the math prof said, and then he left. Yes, well, in any case, Pollard row is pretty trivial in comparison. It really is. And I'm going to get back to the Linux kernel build stuff, but just for the moment, let's just take a look at number 7. Number 7, it's going to start getting big. Oh, baby. That right there, that number is, I think the Linux factor will come back and say, ouch. No, it's going to work on it. It's going to work on it. CPU temperature up to 72 degrees Celsius, and I'm amazed because I was expecting that the factor piece of software that's just, the standard stuff that you get in Linux or Unix would come back instantaneously and say, nope, I'm not doing that. Okay, I'm not doing that. Has anybody been able to find the name of the man? I can picture him in my head. I can't remember his name. This is also nominal aphasia. Okay, nominal aphasia. You know what? We're not going to get an answer to this anytime soon. I think we should do Pollard-Rowe. We'll use the Pollard-Rowe algorithm, which is on the IBM Power hardware running Linux using the kernel that I built, using the code that I wrote, and, the name of the man who did Mercine 67 manually on a chalkboard. Mercine 67 on a chalkboard at a math conference. Frank Nelson Cole. Thank you. Frank Nelson Cole. I had it memorized. It was in my head and I've lost it. My brain is failing, man. My brain. Frank Nelson Cole. The man who stood up at a chalkboard. There he is. Frank Nelson Cole. I can visualize the man's face. Stood up at a chalkboard and said, let me show you something. He didn't say a word. He identified the factors of Mercine number 67, right there. Oh, and before we get into Lucas Lemur, but because Edouard, si vous parlez en français aussi, Edouard, Lucas Lemur. Lucas Lemur, there's a really fairly trivial primality test that you can do using Lucas Lemur that will tell you if a number is prime. You can tell if a number is prime, but it ain't going to tell you the factors of anything. Okay, Lucas Lemur primality testing is actually really cool, and it's used all the time. Yeah, this is the guy who Cole's so-called lecture in 1903, October 31st, Halloween, 1903, time traveler. This guy is proof that time travel happened. Okay, this guy's a time traveler. During Cole's so-called lecture at the American Mathematical Society, he approached the chalkboard. In complete silence, didn't speak a word, and then he calculated M67 with the result being, M67. By doing 2 to the power of 67 minus 1 on the chalkboard. Then moved over to the other side of the board and wrote down the 2 factors and worked through the tedious calculations by hand. Upon completing the multiplication, he demonstrated the result equal, proving Mercine 67 is a composite number. He took a seat, not having uttered a word during the entire hour-long presentation. Standing ovation, ladies and gentlemen, Frank Nelson Cole, time traveler. Time traveler, I'm telling you. People like this, they're out there somewhere, In any case, I don't think he used Pollard-Rowe in order to do that. I think that, isn't it saying here he was a compatriot or a colleague of Edouard Lucas? Who demonstrated in 1867 that M67 must have factors. sorry, that's Lucas-Lehmer primality testing. Yes, we can do Lucas-Lehmer primality testing should anybody wish to look that up. Sorry, Lucas-Lehmer, L-E-H-M-E-R, primality testing. There, well, we'll do that one. We'll go there. Okay, there you go. Lucas-Lehmer primality testing. You know, the algorithm is laid out for you there. Again, you're going to have to deal with, GCD, greatest common factor, which is one of the oldest algorithms known to man. Euclid, I think it's Euclid, another ancient Greek mathematician. In any case, the Lucas-Lehmer test is an efficient and deterministic primality test, meaning it works. If a number fails the Lucas-Lehmer test, then it has factors. Right? Got it? If it passes the Lucas-Lehmer test, that's a prime number. It's a very trivial and very fast way to determine, is a number prime or not prime? But it can't tell you a damn thing about the factors. You need a guy like Frank Nelson Cole to walk up to the chalkboard and he shows the world, yeah, Edouard Lucas, absolutely correct. This thing has factors, and he figured it out. Anyway, let me get over to Pollard Row here, because on Pollard Row, sorry, my machine finally kicked out a result, and it actually goes right off the screen. I mean, if I resize this, yeah, it goes right off the screen. I lose a digit. So here's the two factors right here. Here's the two factors. So those are the factors of Fermat 7. Pretty cool. I don't know how long exactly that took, but I don't care. Next, let me take a look at my Pollard Row code here, and I'm just going to take a look at the AMD 64 stuff. Yeah, I'm using libgnp, libmpfr here. These are your basic libraries for multi-precision math. The GNU multi-precision library, and then MPFR, si vous parlez en français aussi, is going to be a multi-precision library, but there's a French expression for it. I'll save you the hassle and let you know that MPFR depends on the GNU multi-precision library, and all of this is going to need -LM, which is going to be math. You're going to need that. In any case, it looks to me like I went with something called PRMPFR quiet and nothing else. So I reduced it down to something quiet. Just a second here. I just want to take a glance. I can't remember when I wrote this. 2019. So fairly certain. Okay, so that's my GCD up there. Yeah, so there's my GCD using, again, these are MPFR variables and whatnot. And the rest of this is my Pollard Row. Yeah, where I'm actually doing input try. See? In the C programming language, you can use goto. It's perfectly fine to use goto in the C programming language, and anybody that tells you otherwise is an idiot. Okay? Multi-precision floating point reliable. I thought there was a French name for it because everybody is working in Nice, France on it. Pretty sure everybody's at INFR, INREA, all the research work, and on top of that, they're doing a proof. They're working on a proof of the software. Still, that's in progress. Anyway, no, okay. I am sorry. In any case, Pollard Row, etc., etc. See, these are labels where, to make a long story short, handling big numbers means that sometimes you're going to run into a loss of precision where a calculation will happen and you know that the result is not accurate because you ran out of the number of bits to represent the data in memory. Well, no problem. When you got these libraries, you just make larger, wider variables to work with in order to handle the loss of precision. So this particular piece of code, I wrote it such that it dynamically reallocates the precision of the variables in order to handle loss of precision. And that way you always get a good result. It just may have to sometimes rejigger memory a little bit. It's really easy code, actually. The whole thing is written, you can read the whole thing, no problem. The reason why I'm looking at this make file is because I know that there's an error in this make file, right here. I know there's an error. Yeah, that's wrong. And I don't even know if I'm doing sysinfo anymore. Am I doing sysinfo? I don't even remember the last time I looked at this. I'm gonna just give this a hack. Just gonna give this a quick hack. Oh, this is not gonna work. First off, it says mcall FreeBSD right here. Okay, that's not gonna work. That's out. Ding, 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 ding. That's all fine. I'm gonna put in the sysinfo anyway. I don't even know if I'm doing the call. And if I'm not doing the call, then I'll put it in, right? And the reason why I call it MPFR quiet is because I did variations of this which were really verbose, okay? They were really verbose. Am I even doing a sysinfo? Let me check. I don't know. I got no idea. Yes, and it's wrong. No, well, yeah, but the thing is, it's there and it's wrong. I've made some changes, you know. I've made some changes, and linkers and loaders, that does sound like an excellent book. I'll tell you what's wrong, though. This sysinfo right here, that's wrong. Wrong, 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 wrong. This is actually taking a parameter now of int verbose to determine to what degree do you want verbose. So I'm going to define verbose here as 1. There we go. And then when we do the sysinfo call down here, I'm just going to stick verbose in there. That's all. Okie dokes. And we should be okay. We should be okay. Maybe. Who knows? Let's give it a try. All right? Yep. No one knows how to write a good linker 70 years after we started writing them. I believe you absolutely. I thought that Ulrich Drepper from Red Hat was one of the absolute experts on the topic. Just a second. Let me just run this. It should come back and say fail. Give me a test number and bit precision. Okay. All right. So let's do that. Let's give it a test number. So the test number is going to be Mercine. We'll go with something a little bit smaller. Okay. We'll start off with this. I don't know how many bits I need for that. I don't even know how many digits is that? I don't know. I'm going to say 64 bits. Just for giggles. I'll say 64 bits and then let my code do what it does. Which it does. It says, oh, I think, you gave me this number. That's what it says up here. This is the number you gave me. No, that's not the number. See? 551617. Somehow, it was interpreted with 64 bits as 551616. We lost a bit someplace. Incorrect data on input, likely caused by insufficient bits of precision to represent the data correctly. What I did was, in the code, was it said, how many bits are we using right now? We're using 64, so chuck in 32 more. 32 bits, right? So at which point, we switch to 96 bits of precision. Now we can handle the input data. We start doing the factorization, and away goes Pollard row with 96 bits of precision. And at loop 3, we have a loss of precision. We lose the ability to handle the data, so I simply go, chuck in another 32 bits of memory. No problem. Now we got 128-bit integers. So 128-bit integers, it keeps on going, and we're done. And there's our factors. Now, why am I printing out these factors as floating point numbers? I don't know. 0.000 points. I don't know why I put the 0, but anyway, those are the factors, and it came back like that fast, right? That fast. And 274177, and then factor of this is, oh, we just need that, right? 274177. Looks good. Looks good. Whatever. Why the choice of an additive increase and not a listen, it's 4:30 in the morning. I've only had one coffee. I have no beer, no whiskey, and you're using 5-syllable words. Multiplicative, because it's really easy to chuck another 32 bits on. That's why. You know, that's why. To make it easy. Let's do this number. Right there. That's Mersenne. Sorry, this is Fermat 7. We're going to do that. Fermat 7. Okay? So we'll give it a big number. I know. We're going to need, you know, more than 64 bits. Let's go to 128 bits here. Okay? And away it goes. This gives me an opportunity to walk away and make a cup of coffee. You know? Make a cup of coffee. Yeah, I know. Term cap. Hey, man, did you get my email? Did you get my email? Because the toque is on the way. It's got to be somewhere in Canada. It's got to be somewhere in Canada. Okay, I'm going to track that down. The hand knit toque, I'm telling you, it's on the way. Essentially, we read the L sections, and we do the mapping. Yeah, it's near. Okay, no problem. You haven't checked your email in a couple of days? Okay, let this do it. We've already jacked up to 256 bits of precision. We're factoring that number, which is Fermat 7. This is Fermat 7, okay? Which gives me an opportunity. You know, smoke them if you got them. I'm going to go make a coffee. It's time for coffee. And then we'll get back to the Linux kernel stuff. I can see that's cranking later on, and coffee's doing its thing. So let's leave this alone. It gets me back to the problem with this machine, Hydra, where what Linux kernel are we going to build? Well, you know what they say. If you got the opportunity to do something, do it right. Let me go back here. Frank Nelson Cole. It's funny, I can't remember this guy's name, but I can remember the fact that it was Mercine 67. Go figure. It's just one of those things. Let's see. Yep, the Linux Foundation, annual report, etc. Let's go to kernel.org. It's Tuesday. So, okay, there it is. 5.16 RC4. Why not? Right? Why not? Give me a reason. Curl. I gotta get my coffee. I'm still making what I call dirty coffee in a French press. There's always going to be some grounds at the bottom. Okay, that's got to sit in the French press for at least, give it a couple minutes to soak. Oh, yes, thanks, man. You got my email? Okay. I'm just telling you, I'm going to be living in it. I'm going to be putting it on my head, and I'm going to live in it. If your wife hand knit me a toque for Canadian winter, I'm going to be living in it all the way until March, at least the month of March. I'll be living in it, okay? Okay, what we have here, there we go. Okay, so RC4 right there. So let's make a build directory. This is in USR local. Now, just for the sake of clarification, now we're going to hear some disk thrashing. Okay, there's going to be some disk thrashing. Source, this, go. No, I don't hear any disk thrashing. Don't feel obligated to do anything? Dude, I'm in Canada. It's winter, okay? I'm going to be wearing it. Okay, Linux 5.16 RC4. For the sake of clarification, you might say, why am I going to build the Linux kernel, especially a release candidate? And there's two answers. One, because it's fun and I haven't done it in a while. Okay, it's been at least a month or so since I've built a Linux kernel. Okay, at least. Two, yeah, there's multiple answers. Two is, this machine is brand new. Fresh install. I don't have any of the development tools. I don't have any of the dependencies that I'm going to need to do this. That's why the title today is Linux kernel without a clue. Meaning, stumble into it, and let's find out, what do I need as a minimum to do this? What can anybody do? What can anybody do? Anybody can follow these instructions of what I'm doing. Anybody can do this. And trip over and fall and make mistakes, make a coffee, and then go, oh, that didn't work. I'm missing, SSL dev package, or I'm missing this package, or, oh, I didn't realize I have to also do this. There's little things that get in the way that will slow you down and stop you from getting a Linux kernel built. And they're usually just little things, okay? It practically builds itself, okay? Really. Now, the other reason is, as some of you know, our friend in France, the man with the panther, Mosh, he's got a class with students for Linux. And so I said, no problem. Let's set up a server such that you and your class and your students can use it for doing basic Linux learning type stuff. No problem. I'll set that up and get that going. He was thinking of a VMware virtual machine or something hosted someplace, whatever. And I said, if it's got to be running for months and months and months without costing anybody a dime, no problem. As long as I get a beer out of it, I'm happy to help students, to help people learn. Oh, come on, I'll just do that. I gotta get my coffee. It's getting stronger right now in the kitchen. I can hear it right now going, I'm done. Come get me. Where's my coffee? Caffeine. Ah. Alrighty then, coffee. Nature's brain elixir. Coffee complete with coffee grounds floating on the surface. That's how you know, alright? How should I follow your instructions on a FreeBSD box? Well, you're going to need a QEMU instance, a virtual machine or something, okay? Also, if you listen very closely, you might hear a cooling fan kicking in because, what did I do? I just got something on my monitor here. Ah, the heck with it. This is going to take some time. Looking for a factor of Fairmat 7. We haven't even gotten to Fairmat 8 yet. And hold on a second, I got to calculate 8. 2 to the power 2 to the power 8. Well, 2 to the power 8 is 256, so this is 2 to the power of 256. Plus 1. Whoa. So it's this number plus 1. It line wraps in a funny kind of way. There's like a continuation character there, so that's a big number. So we're talking 2 to the power 256. By the way, it should be obvious to anybody that if you need to handle and process a number, which is 2 to the power 256 plus 1, you need 256 bits of memory to represent that integer plus 1 more, right? It won't fit into 256 bits. Pretty obvious, right? Having said all that, I need to make reference to a reference machine. Just a second. A machine that builds. Do I have a cyan? Oh, that's right. Harry can't see cyan. That's gray. As far as he's concerned, that's the color gray. Here, I'll just switch that like that. Jesus, nice big font though, right? You gotta love that font. Let's go to sell this. I often wonder, how is Jesse Shanahan doing? I don't know. One of those wonderful people who educated, edified. She was streaming yesterday. No way, doing some teaching. Excellent, because she's in Sweden now. Isn't she in Stockholm? I mean, I don't mean she's in Stockholm, you know, for that big prize in physics or mathematics. Well, no, mathematics is the Fields Medal. Go figure. You don't get a Nobel Prize for mathematics, but yeah, she's in Stockholm now. I've actually written down some notes someplace that's saying, oh yeah. When I had the opportunity to do a stream with her and talk to her and email back and forth a couple times, ask her some questions, and she gave me brilliant stuff. And I just said, hey, life is too short not to pay attention to such people. Yeah, Jesse Shanahan. Okay, so I've got my notes from 5:15. I've even got a README right there. There's a README right there. So that README, let me just cat this sucker out. A lot of stuff is going to not work, but at least I've got a reference build here. What's that? American people are just entirely too crazy for her. Well, Rob, she's not wrong. Ooh, that's coffee. That's coffee. Let's take a look. What did I do? Oh, we need a key. We need a key. Yeah. See, in the Linux kernel, once you unpack it, there's a directory called certs. Right here. Certs. Certificates. The idea being every kernel module that gets compiled also gets signed with a self-signing certificate. Basically, we generate a certificate authority, then we generate a key to sign with based on that CA, the certificate authority. I'm not really good with OpenSSL certificates, not really, but the concept of, signing and then verification of the signature of a given binary, that we get, which basically says the kernel has the opportunity and the ability to verify that a given binary kernel module is built for that kernel by checking the signature. Very important feature. I don't know to what degree it's been checked for like security holes, but we have to address it. So, in this search directory within, I'm just going to slow down now. Once you unpack your kernel sources, go into the search directory, go in there, and generate a thingy that looks like this. We're going to generate a key, make up a name, X509, because I'm going to generate a new key, signing authority, key, the whole 9 yards. X509, to be completely honest, we could call this thing, donkey.gen key or something like that, but it is an X509 key. Insert, paste, stop. Now, let me just take a look. It's a 4096-bit key. That's more than enough. Okay, that's going to be the common name component, which is this. There's the common name component. And down here for Gen Unix is the basic stuff that says it's a CA, it's a signing authority. Your kids would say, Uncle Dennis, what? No. Don't you worry. Those little nephews and whatnot, they're out there. They're out there. Okay, this doesn't make a huge amount of sense to most people. It's a request. It's a request to create a signing authority key. CA, certificate authority. Certificate authority. Geez, this is hard stuff to explain because I'm not very good with it. And I'll get up to speed. I'll try to get the vernacular a little bit better. I'll try to have a better handle, a better understanding of the fact that a signing authority or a certificate, which is an authority, can then generate and hand out keys to other people or to other clients. Then you can have something like, say, a client-server relationship, like, say, Apache Web Server or Nginx, which is so hot right now. So hot. Nginx, so hot right now. But Apache is still the big dog out there in the internet. In any case, just saying. In any case, you end up having the opportunity or the ability to have, say, a self-signed certificate on a web server. And provided you give a key out to somebody with a web browser, they can then access your server, authenticate. The verification of the key with the certificate authority will happen, be handled by the server. And then you can begin secure encrypted communication back and forth. And it'll be really exclusive because if you create your own certificate authority, then nobody can access your server or your site unless you give them a key. Another way around this is you got things like, right, SSL certificate corporations, entities out there, like, what's it called? Let's Encrypt. Let's Encrypt, greatest thing that happened in the last 5 years. Is it the last 5 years or the last 10? Best damn thing. Let's Encrypt. I don't have to kick out money to VeriSign. I don't have to kick out money to Komodo. I don't have to kick out money to anybody. Let's Encrypt is a CA. And they're a well-known and respected CA, and because of that, they can issue keys to your server and your Firefox browser, your Chrome browser, whatever. Now you can access securely and encrypted web servers and sites. This is different. What we're doing is we're going to say every kernel module to be built by the Linux kernel process. Every module is going to be signed. I'm going to generate my own certificate authority, self-signed key, and then that's how the kernel will always be able to authenticate and verify that the kernel module is built correctly. Sorry, let's not talk about built correctly. Let's just say the kernel can verify that the kernel module can be trusted. That's the whole idea. Yeah, it's good. It's a streaming service, any kind of communications. Yes, 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 and yes, I have been thinking about this. So there we have, right there, our X509. This is our request. This is our common name, and this is the data related to that common name and the fact that we're creating a certificate authority. Okay, the command line to do this is loads of fun. It's loads of fun. Here it comes. You ready? We're going to use OpenSSL. We're going to request new, gotta love this, nodes. Yeah, well, we're specifying a bunch of options here. The fact that it's going to be SHA-512 and it's going to only be valid for 90 days. By the way, little secret. If you build a Linux kernel and you use your own certificate authority and it's got a timeline of validity of only 90 days, what do you think happens 91 days later when you're running that kernel? Answer is nothing. It doesn't do a damn thing. The kernel does not reject kernel modules even though the certificate authority and the keys have expired. See, I think that might be a bug, but, you know, I was going to get around to it. You know, it's one of those things I was going to get around to real soon now. Okay, so we're doing a batch X509. The configuration's in this file. Well, it's not in a subdirectory. It's right here. There it is. Boom. That's the file. Got it. The output format's going to be what's called the PEM. Does anybody know what that's called? Portable encryption messaging, or portable something format. I know, really helpful, right? Okay, the output is going to be right there. The output's going to be the kernel key.pem. Everything goes out into this one file, by the way. Key out is going to be this kernel key pem. We're done. Hit me, baby, one more time. Go. Generating RSA private key. Privacy enhanced mail. Thank you very much, sir. You see, you gotta love the ability to have, to have access to smart people who can look stuff up. Privacy enhanced mail format. And so this output file, well, it looks like base 64 encoded noise, right? I mean, there it is. This is all base 64 encoding is what this is. Begin private key, right? And begin the certificate. There's the key, there's the certificate. It's all right there on the screen in PEM, privacy enhanced mail format. Real user friendly, I know. I know it's really user friendly. Anyway, I'm just going to put that in a README file. Okay, I'm going to put that in a README file because we're expecting things to go wrong. I am, anyway. I don't know if anybody else is, but I'm expecting things to go wrong. Let me just copy and paste this. I don't really need the key. I don't need all that in the README file. I just need this stuff. And just to give you a heads up, things are gonna go wrong on purpose. Okie dokes. Things are gonna go wrong on purpose. Take it from me. Set your term to X term. Okie dokes. Not VT100. Because reasons. I mean, if you want to handle everything in really horrible interface for doing the menu config, set it to extern. Okie dokes. Make your life easy. Now comes the silly part. On Enceladus, I use a pre-existing configuration. Now, I don't have a pre-existing configuration. Or do I? Hold on a second. Let's take a look in the boot directory because that's where we'll see our config, our kernel, okay? There's our initial RAM drive, init.rd. The initial RAM drive, when your machine boots and gets past the Grand Unified Bootloader, grub. This is grub 2, actually, grub 2. Is that grub 2 or grub, just grub? Let me think. Anyway, once we get past our bootloader, we're going to have to find a way to RAM disk. Yes, initial RAM disk, RAM drive, RAM disk. Yeah, nobody uses grub 1 anymore? Nobody? Just not good enough. You know? The initial kernel that gets loaded into memory right here, we don't have any kernel modules. We don't have any kernel modules to give us access to any hardware. Unless, you know, you're smart and you built a pile of stuff right in to your kernel, which makes it bigger, but now you don't have to go looking for drivers to get access to hardware, regardless. System map, it would be really wonderful if somebody could look into that for me. Okay? It'd be really wonderful if somebody could look into that. I'm not what you call a Linux expert, okay? Probably doesn't say much. Well, the real system map is in the Linux image debug package. Go figure. Good question. I've got to research that. I haven't given too much concern. Like, you can tell, look at these system maps. Like, the system maps over here are big, right? I mean, these are big, full-rounded, the real thing. These are built by me, though, right? These are built by me, all this stuff. I would suspect it contains, as the package name would suggest, a ton of debug data. Where do I look if I want to add a custom FreeBSD service? Man or C? I don't know. It's going to go, it's basically System 5 Release 4 init stuff, right? Yeah, etc.rc.d. Hold on a second. This is a little bit of a segue. Just want to take a look. Yeah, it's ASCII text, all right. How many lines? 129,000 lines of text. Let's take a look. Well, I have a sneaky feeling it's addresses and symbol names of every damn thing imaginable, including the doorbell in your kernel. Well, there you go. Look, you got a super doorbell, and then you got a doorbell. Exception handlers, performance monitor, VXX unavailable. Well, I'd have to do some research into this, but it's not going to be a trivial answer. And there's 129,000 lines of this, which means, look at just, the last. You'll notice this is going up by 32 bytes every time, right? F00, F20, F40, F60, F8, that's 32 bytes. Every single entry has a 32 byte slot in memory. Ooh, except for these guys. These ones are a little bit smaller. This guy went from 38 to 40. Hey, that's only 8 bytes. I don't think we can make some generalized statements other than the fact that they're 64-bit aligned. These are all 64-bit aligned addresses. let's not get derailed. We'll come back to this. Bing. Bing. Let's get back over here. What I really want is this config right here. That config. That is a Linux kernel config from, I was going to say the Debian people. We might say Debian on it. Let's take a look at the first 20 lines, just for giggles. All right. It might say Debian, it might say Dev1, right? Let's see. Yeah, automatically generated, do not edit. Watch me. Okay, Debian, and away we go. You know, what version of GCC was used, linkers, and then there's thousands of lines of stuff. All I care about is, okay, let me say this slowly to anybody who's ever going to listen to this YouTube rant. Okay? At the moment, the machine is running with this kernel and lsmod, a whole bunch of kernel modules are currently loaded. System's running really great. We've got no problems. We got everything from diddle-I-do to damned if I know in here, right? And we've got 3,400 more kernel modules someplace. 3,900 modules. Now, I don't want all that. I don't want all that. Maybe we can thin that out, right, a little bit. And you know what, Nico? It took me 30 seconds to figure out what you just said. You know, GLHF, Golf Lima Hotel Foxtrot. Good luck, have fun. See this config? I'm going to copy it. We're currently in the Linux 5.16 RC4 sources. I'm simply going to take a copy of the existing Linux config, which currently works right now, and put it into a file called, of all things, .config. You with me? .config. No, I figured it out. And here's where things are now going to start to blow up. Here's where things are going to break. Because we don't have any development tools. We had no development tools installed in this machine. Nothing. That's why I said the title today is Linux kernel without a clue. As in, we're just gonna figure it out one step at a time as stuff breaks. What we should get out of this is a relatively minimal set of steps that tell us what we need. Oop, I didn't want that. I want this. I'm just adding on to the bottom of the README file. Whoa, write and quit. Okay. We don't have make. We don't have a compiler. If you think you're going to compile and make up a Linux kernel with no compiler and no make and no tools at all, none, it's not going to happen. Now, there's a couple I know about off the top of my head. You know, a couple things. We should be able to do this. apt-get install. Yeah, compilers are overrated. Yeah, just assemble the Linux kernel by hand using a needle and a butterfly. Sure. We're going to install something called Build Essential. I think this is like minimal. This is like just the beginning. Build Essential. There's other stuff we're going to need. This is going to blow up. But we need this. This gives us our compiler and a few other things. Let's see what it says. Whoa! The following additional packages will be installed for Build Essential. We get bin utils. We get fake root, which nobody's used in years. C++ compiler. C compiler. A pile of other stuff. libc6, well, libc development libraries, libcrypt stuff. Yeah, oh, there's make. There's make right there. Make. Patch. Yes, exactly. Yes, the butterfly. The butterfly was what I was making reference to. And you got that. I gotta drag that in. The XKCD comic right there. Real programmers like Mel. Emacs has a command for this. Yeah, real programmers. Isn't that funny? I can't just extract the image. That's what I wanted right there. Just, you know, Emacs. Anyway. No kidding. Emacs. Which is now an operating system because it's even got a game built into it, right? Yeah. Sorry for the stupid question. A lot of these machines are VMs, right? No, this is real hardware. No, this is real hardware. Yeah, I was going to do VMware vSphere. Yes, I was going to do VMware vSphere. Have I given any thought to Beehive? Not there yet. FreeBSD Beehive, I've spent no time looking at all. When I tend to look at virtualization, there's only two directions I tend to go. Yeah, there's a third way out in the left field there someplace all by itself playing. But there is a third. But the first one is I go to VMware vSphere because it works. It's real expensive and it works. There's VMware vSphere. If I need to emulate a funky piece of hardware, then I use QEMU. Open source, get the source code myself, build it myself, QEMU. I've had great success with that. It's slow, but it works. And it's free. And then way over in left field over there someplace is a thing called VirtualBox, which got initially given a hug from Sun Microsystems, and then Larry Ellison came along and it's been absorbed into the farm of the Oracle world. I don't know, I just don't have any love for Oracle. I don't know why. And that's it for virtualization in my life. I guess I can add Beehive in there. Here, I'm going to say no here. You know, if anybody was ever to follow this video in order to build their own Linux kernel, all I can suggest up front is get some beer. Hey man, we're going to do this again. I'm going to put in the exact same command, but it says suggested packages. Let's look. I'm trying to find, okay, auto tools. libtool, flex, bison, GDB debugger, yes, yes, yes. We need all of this. You know, I've got coffee right now, but I can do this with beer, no problem. I just don't have any. I don't know what causes that, but there's no beer. Okay. Build Essential, AutoConf, AutoMake, libtool, flex, bison, GDB. Now there's some stuff we need, but I want to show how things blow up, and we'll figure it out. So we go to install this stuff, and I'm just going to say yes. Just do it. Just do it. Just come on, install. And you'll notice we're going to fetch all these packages. This is Chimera. We're running Chimera. Exactly, Rob. I'm trying to do a little bit cleaner, more family-friendly YouTube stream, because maybe some student somewhere is going to go, I got to build a Linux kernel and I've got no idea how to get that going. And this is how it's done. And we're still going to make mistakes. A lot of stuff being installed. A lot of stuff. Oh, yeah. Yeah, you're a student, but sorry, senior PhD doctoral students that are also instructors and whatnot, I have a sneaky feeling you already know your way around this process. But that's okay. You're a student. That's absolutely correct. And you may come up with questions, but more often than not, you usually have answers like, who was that guy who stepped up to the chalkboard and hand calculated the factors to Mersenne prime number 67, which wasn't prime at all, thanks to Lucas Lemur primality testing, Edward Lucas. And you come back and you say to me, Dennis, that's Frank Nelson Cole. How did you forget that? I don't know. Okay. Oh, you found something called minimum requirements. Yeah, about that minimum requirements page. Let's take a look. Because I haven't had really great success with this documentation. Hold on a second. We're going to need, no. That's no. Riser FS stuff, no. No, we don't need this. This is what? Minimal, no. This is not true. Bison, didn't we just put in Bison? Okay. Flex, Bison, Perl, SSL, that's fine. No, there's some other things we're going to need. Beyond OpenSSL, where there's other stuff we're going to need. Yeah, why don't we just fall on top of it? Yeah, we're not going to make that joke. Yeah, we're not doing that joke. Okay. We are in the Linux kernel source directory. We've got an initial config. You see this, September 30th, this .config. I'm going to have to overwrite that. I did something wrong. We have to do something called make Mr. Proper. This is a cleanup process. Cleanup. And it eradicates all manner of stuff out of your source tree, making sure your source tree is nice and clean and ready to go. And it blew away my certificate stuff. See what I mean by making mistakes, folks? Funny enough, the kernel key is there. We've lost the request. We've lost the request data. That's pretty funny. And it blew away our config also. So we might as well as just recopy that back in from boot. Okay, so copy -p from -boot. We're going to take this config right here, put it right back in again. I can't believe I forgot that when you do make Mr. Proper, clean everything up, get it ready for a fresh build, it'll blow away stuff that you did. It doesn't blow away the kernel key. Go figure. Oh, we're not doing a minimal build. We're doing a big, fat, stupid build. To a certain degree. Big, fat, and stupid. Yeah. I want on the README, I want this X509 Gen key. I want that back in the directory there. We don't really need it anymore. We don't need it, but I'd like to keep that around. So I'm just gonna put that back in. Done, like that. Right, quit, done. Okay. Whoop, LS. Well, let's watch this blow up, because I know it's gonna blow up. Because I know that there's other packages we need. And I'm just gonna change the font size to make it a little less bonkers large. That wasn't really a great change. Let's see, let's make this a little wider. Any luck at all, it should all fit on the screen well enough. Let's see, columns equals 120, lines 43. Yeah, that'll do for now. That'll do. Okay. You're running OpenSUSE. Yeah, there's lots of ways to optimize this process. We're now going to do a kernel config. Menu color, black background, something. What? I gotta let you know, the make file, the Linux make file has got lots of stuff in it. If you go to just view the make file, okay, we can go looking for things like menu config. It's in there. Read in dependencies to all kconfig files, make sure to run. There's all kinds of documentation in the make file itself. You can read your way through this. You really can. Oh yeah, you can do monocolor, you can do different colors and stuff. But there's very few options actually. There's to the menu config, but there is. Let me just take a look if I can find the proper. There we go. Make Mr. Okay, delete the current configuration and all generated files. Make clean is probably a little bit safer. And then distribution clean is remove editor backup files, patch leftover files, and there's lots of documentation in the make file should you feel like reading it. Okay? I really just want to get on with the menu config. There's this make menu config, which brings up a menu, maybe. Okay? Somebody count down from 3 because this is gonna blow up. You ready for this? It's gonna blow up. 3, 2, 1, fail. Oh, told you. I've been here before, boys and girls. I've been here before. It blows up. It starts saying N curses. N curses. We need curses. Curses, you Red Baron. That's an old Snoopy joke. We need various flavors of it. I'm going to look on another machine that we know can build kernels no problem. And over here, I'm going to do a deep package query on another machine. All right? You don't need another machine. I'm doing it for you. And over here, I'm just going to go grepping for curses and see what comes up. There's a bunch. Fairly certain libn curses dev. No, hold on. There's this. There's wide character stuff we need. Yeah, okay. We're going to install some of this. Yeah, we're going to install some of this. Okay. apt-get install. This I want. Next one. I want this. I want this. Wide 5. Wide 5 dev. And this right here should be enough to just bring up the menu. Let's take a look. It says we've already got a couple of these. Some others we don't have. Well, it's obvious we've got some stuff missing because the process blew up. I'm gonna shrink this down a bit. It's a little big, you know. There. Okay. So we installed. Let me just scroll back up. This Lebian curses dev. Now ncurses 6 was already in there, and it says for wide characters it was already in there also, but these two were missing. Previous release. Okay. Let's try it again. It blew up last time. Right there. Unable to find the ncurses package. Install lib ncurses dev. Okay. Alright, so we're going to do make menu config again and see what happens. Make menu config. One more time with enthusiasm. Go. Working, 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 and we land. Ta-da! And that is the Linux kernel configuration menu. It's a little bright. It's a little bright, and as Zero Day was saying, there's a bunch of options that we can use to just tone this down, you know, at 20 after 5 in the morning. Let me just tone this down. I'm just going to hit exit here, okay? Exit. Do you wish to save your new configuration? Say yes. Always say yes. Even if you didn't change anything, trust me, I'm using a copy of a Linux kernel config from a different kernel version. It just cleaned that up. There's options. There's options for menu config. There's monocolor, which I'm thinking is going to be black and white. There's the black background, which would be nice. Dark mode. Classic. To me, I think classic is going to be the exact same as the blue one, right? The blue, we just saw the blue and gray thing. Classic. Probably I haven't seen it since the 90s, and I don't care to see it again. What I'm going to do is I'm going to change this to, just let me back up. Right there. Make, and then all in capitals, there's this menu config underscore color equals, and then we go to lowercase, gotta love consistency, black background, menu config. This is the exact same thing I did up here. The difference is I'm chucking in an option right in the middle. Okay? Let's see what this looks like. Go. That's a little bit easier on the eyes, huh? Oh, you've been working with Linux since the 90s, eh? Okay. I don't want systemd. Alrighty then. Yeah, I think SUSE is a great distro. And were they in any way, shape, or form connected with Scientific Linux back in the day? Wasn't there Scientific Linux also? But I think Scientific Linux, or maybe I'm thinking the year 2003, 2004, Scientific Linux, SUSE Linux. I remember messing around with Beowulf clusters and I was using something called Scientific Linux, and I was using SUSE Linux, and that would have been 2002, 2003, something like that. Okay. You've got a system that boots in 830 milliseconds. That's offensive. That's a vulgar display of power. There's a reference to a movie from the 1970s, folks. A vulgar display of power. Okay. Local version. Append to the kernel release. I tend to do that. I call it Gen Unix. Gen Unix. Little tag goes on the end. Automatically append version information to the, yeah, chuck that in. This we're going to change because we're not on 5.10.09. We're on 5.16 RC4. So we're changing this. I'm not going to bother with the AMD 64 because, you know, we're on AMD 64, right? Beowulf is based on Slackware? Oh, as was the first SUSE distro. See, I remember SUSE and I remember Scientific Linux. I'm not going to change too much, but we've got to turn off some stuff. Desperately. We have to desperately turn off some stuff. Not too much. Let's see. Oh, this is wrong. We're building a server. Preemptive model. Voluntary kernel preemption. Don't go looking for real time. We're not going to get real time, but I'm going to want no forced preemption. We're going to make sure that we got an equal distribution of CPU priority being given to the processes in the machine. Equal. I don't care if it's a user in the front end or it's a system process in the back end. I want equal priority given right across. Okay. Yeah, I've heard good, yeah, good, well, I can tell you right now, Scientific Linux, yeah, good stuff. Mind you, I'm going all the way back to like Linux kernel version 2, you know, 2, when did version 3 happen? Oh, I don't want to talk about it. I feel old already. Does anybody remember Red Hat Zoot? Red Hat Zoot? Anybody? Red Hat Zoot. Probably one of the last times you could download Red Hat Linux Zoot and install it in a Spark 20, in a Sun Microsystems Spark 20. Yep. Red Hat on Spark. Okay, let's take a look at config support. I don't want to make too many changes because I want this to be a relatively short video to get this just compiling, actually to get this blowing up. We got to get this to fail. We're going to fail fast, right? That's what we're going to do. Scheduler features, no, I don't want to talk about RT. We're not going to do real time. But uniform memory architecture scheduler, let's not touch much of this. I think boot config support. Yeah, we'll put it in anyway, whatever. It's one of them trivial new fancy golly gee whiz things. Let's see, that's it, get out of there, that's it. Never heard of it, no, well, who would, right? Red Hat, Zoot. You gotta go back a lot of years. I probably have it in a box somewhere, you know. Let me get out of here. I'm just gonna switch over to exit at the bottom. Hit enter. It's a 64-bit kernel. Now, processor type and features. This is an AMD Opteron type machine, so symmetric multiprocessing, we absolutely need that. But, oh, Linux guest support. I don't need that. Processor family? Wrong. We're not going to do generic x86. I'm going to go for Opteron, Athlon 64, the Hammer, the AMD Opteron K8, which is basically your very first baseline 64-bit processor that we ever got in the x86 world, was the AMD Opteron. build your kernel for the AMD Opteron, the Hammer, the K8, unless you got reasons for something special, okay? Yeah, this will run anywhere. I mean, this will run on any 64-bit machine. But I'm turning off this Linux guest support because we're not going to do any virtualization. Maximum number of SMP processors. I don't need that. And I don't need 64 freaking processors. No. Give me 8. And that's it. Okay? 8 processors. That's all I need. Anything more than that's ridiculous. We're not running a supercomputer here. Next. Some things here. Oh, there's a vendor option down here someplace too. AMD microcode. Well, there's some stuff here we don't need to touch. We don't really need to mess with it at all. Let me just keep looking. I'm looking for obvious stuff to either just turn off or, nah, we're done. We're done. Yeah, I'm not changing much of anything here other than I want an AMD Opteron Hammer here. Oh, processor vendors. Yeah, let's restrict this. That's it. Processor vendors, we're going to restrict that. Turn that on, hit enter, because now you get an arrow. Intel. Nope. Centaur. No. What? Can somebody help me with this? What the hell is a Zoxin processor? Does anybody know? What is a Zoxin processor? The high gun, I don't need it. What the hell is a Zoxin? The hell is a Zoxin? If unsure, say no. You think? I'm turning that off. I don't know. Yeah, some Chinese Intel clone or something. Something they reverse engineered and stole. I mean, who knows? But we don't need it. Okay, we do not need that crap. Okay, that's it. It's on an AMD Opteron platform. We're out. That's it. We're out. Get out of there. Exit. Get out of there. Okay. Now, a few other things maybe we can turn off. Power management. Suspend to RAM and standby. Forget it. Turn that off. Suspend to RAM and standby. The machine is never going to suspend to memory and switch to standby mode. It will never do hibernation, aka suspended. Turn that off. Turn that off. Oh, it's a continuation of the VIA Centaur. Isaiah. Oh, okay. All right. So it's VIA. We already have a VIA. We have Esther right there. Esther, up and running. There's the blue light. There's Esther. We got a VIA. Hold on a second. Ding, 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 ding. That's it. Get out of here. Get out of here. Just turn off that suspended RAM and turn off that hibernation crap. Oh, it is basically like Esther, but worse? Well, no. Okay, bus options. I'm not going there. No. Okay, virtualization. See this? Gone. Gone. Turn off the entire possibility of running virtualization on this machine. It is never going to run VirtualBox. But you might run QEMU because QEMU does not go looking for special virtualization features in your kernel or your processor. Oh. Okay, general architecture dependent options. Let's take a look. I'm not touching any of this. Nah, forget it. Okay, loadable module support is critical. We need that. And furthermore, we got to be able to sign the modules. Let's go in here and say force module, loading, unloading, versioning support, source checksum for all modules. Next is require modules to be validly signed. We created the certificate authority, we created the bloody certificate. We can sign our modules and automatically sign them. Trust me, do that. you want to make sure that your modules are all being signed by the build process. Next, if you're on a 64-bit machine, go with a 64-bit process, SHA-512. SHA-512 is a little bit faster on 64-bit architectures than the 32-bit SHA-256. Don't SHA-1, don't. Just go with SHA-512. Okay, 512 bits, hash, signatures, secure hash algorithm. Okay, just do that. Next, get out of there. We're done. We're done. That's it. Get out. Get out. Okay. We can trim some more fat. How much fat can we trim? Well, file systems. There's file system support stuff we don't need. Let me just take a look and see. Oh man, partition types. I don't really care about anything other than GUID. What does that stand for? GPT partitions and MS-DOS. And that's it. Advanced partition selection. Oh man. UEFI. Okay, get rid of Karma. Chameleon. I'm going to leave in the Sun partition table just because, I love Sun. SGI. We don't need it. I love it. Silicon graphics. Logical disk windows. Get rid of this. Okay, MS-DOS we need. BSD, FreeBSD stuff. Yeah. Minix, why not? Solaris. This is minor stuff. Macintosh. Forget Macintosh. Sorry. Atari. Oh man. Some of this stuff goes so far back. Look at this. The Amiga. The Amiga was a great machine. The Amiga was a fantastic machine. DEC Alpha. Beautiful stuff. And all this, what is Acorn gone now? That doesn't kill the whole thing, does it? Yeah, it does. Okay, that's it. That's it. Just some basics here, Oh yeah, networking and other drivers to disable, but we're not going to. We are going to build, I want the machine to thrash and do some work, but really the only drivers I need are Realtek. The Realtek driver is all I really need. Not much else. I certainly don't need USB dongles. I don't need any Wi-Fi. If I see any Wi-Fi, I'm going to kill it. Okay? Executable file formats. Oh, this is going to be like cough and A out and whatnot. Leave this alone. Don't touch this. Don't even touch this. Don't, just executable file formats, leave it alone. Memory management. Don't even bother touching any of this crap in here. Except for maybe tracking, let me see, swap. Hold on a second. Collect per CPU memory statistics. That's nice. Nice to have access to that. If you want to write some code to get access to that information. Contiguous memory allocator. Let's not touch that. But the only thing I am going to touch in here, sparse memory. Yeah, leave that. Leave most of this alone. But the only thing I'm doing is I'm turning on collect the per CPU memory statistics, and that's about it. The rest of this, I'm not going to touch this. Yeah. It's not like we can have multiple page sizes either. It's not like we're on Spark or DEC Alpha or IBM Power where you can change your page size. Oh, networking support. This is going to suck. This is going to suck. Oh, wireless. I'm going to go to wireless first, okay? I'm going to get in here, and if I can turn it off, I'm turning it off. I don't want any wireless at all, period. It's a machine with Ethernet plugged into it, and I can't turn off this option. RF switch subsystem support, which is what again? If you want to have control over RF switches found on many Wi-Fi and Bluetooth cards, no. I don't need the module. I'll even plan 9 alone because, oh, hold it, near field, Get rid of it. Near field, gone. Garbage. Amateur radio support. Is this ever gonna go away? Is this ever gonna go away? Bluetooth, make it go away. Make it stop. No, can't, but no, just turn that off. The rest of this, just, that's it. Just, that's about as, let's not mess with it too much, but just, God. Disable IPv6, there's an option. Oh, device drivers. Hold on a sec. Okay, PCMC, card bus, goodbye. Gone. Don't need that. I haven't seen one of them in 15 years. Let's see. Bus devices. I'm not touching that. Firmware, memory technology, I don't need that. That's gone. Don't need it. Let me see. Plug and play. Block devices. Well, I'm expecting to see a lot of stuff in here. I'm not going to touch it. The heck with it. NVMe. Don't need it. Don't need it at all. The whole thing. Don't need it. Please stop. Gone. Don't need it. Miscellaneous. I'm not even going there. SCSI. I'm not going there either. SATA. Okay, I'm just going to build that right into the kernel. The SATA. From who? Oh. Well, it's going to be... Where is my AMD stuff? AMD, NVIDIA, that's PATA, P-A-T-A, parallel ATA. NVIDIA SATA support. I think that's a yes. But this is only for my particular chunk of hardware. Out of heck with it. Let me get out of here. Let's just, you know, multiple device driver support, RAID and OVM. Turn that off. Don't need it. Firewire support. Oh no, gone. Please, bad. Gone. Firewire. Don't need it. Nothing from Macintosh. Don't need it. Network device support. Ugh. What can we turn off? ISDN. That's gone. Don't need it. Networking over USB 4 and Thunderbolt. We don't need it. Don't need it. VMware. Don't need it. It's real hardware. You know. Wireless LAN. WAN. Sorry. Haven't we turned off all the wireless crap? I thought we did. WAN interfaces support. Wireless LAN. Okay, don't need this. Don't need this. USB network adapt. Don't need that. Nope. I can't remember the last time I even looked at SLIP. PPP or PPP. A lot of this stuff we can just ignore it. FDDI driver support. That's excellent. No, don't need it. We can be here all day turning off stuff. I mean, seriously, you don't have enough coffee, you don't have enough beer to turn off this stuff. This is for LACP, link aggregation control stuff. Nah. You know, a lot of this stuff you can just ignore. I mean, really, you can ignore. A lot of this is modules anyway, but Ethernet driver support? Wow. Yeah. Okay, we're gonna need Realtek. I think it's time to ask a question. What do you got? You know, what do you got over there? Just a second. It's not much of a board, but it's a board. Xterm underscore black and white. Let's go ask. You know what they say? If at first you don't succeed, stop, idiot, and go and check. What is the name of the machine? I built it. I just built it. I don't even know what it's called. Hydra. Yeah, Hydra. Yeah, Hydra. There we go. Does this work? That works. That'll do. Okay. Realtek Semiconductor. I knew it. It's Realtek. That's all we need. We just need Realtek. Everything else, turn it off. Every other driver, gone. Yeah, you're building kernels all the time, whereas not me. Okay, VIA devices are gone, Texas Instruments is gone, Tahuti, Tahiti, to what it is. Oh, the Sun Happy Meal. There's some interesting comments in the Sun Happy Meal kernel module code. Okay, we're going to turn it off. Next, all this stuff gone. That's gone. SMC gone. So gone. Gone. And Solar gone. Samsung gone. Rock gone. Renus gone. Realtek. Hold on a second. Now that we're in the Realtek world, I just want to see. Bake that in. Bake that in. Just a second. Just want to check. 8168, 8411, older stuff. 8169, 8168, right there, built in. That's it, baked in. We're done. Everything else. Look at this, look at this. Just turn it off. 3Com, gone. DAPTEC, gone. Gone. You know, AMD, gone. That's for like a Theros, isn't that for Wi-Fi? I think that's for Wi-Fi, I'm not sure. Broadcom, I guess you can't turn off Broadcom. Looks like Broadcom is something you get, whether you like it or not. Huh, go figure. What if I turn off everything down here and work my way up? Just curious. Does it allow me to, or am I just being hammered? Look at this, QLogic, this, Broadcom. You know, here, it's like dealing with Apple or something. You're gonna need this cable. Yeah, I don't wanna pay for that. Yeah, you're gonna need this cable. Just shut up and take it, Chelsea. Look, more stuff we can't turn off. Why? Did somebody cough up money to the Free Software Foundation, the Linux Foundation or something? Like, these things are like locked in. Thou shalt not turn off. It's locked in. DEC, gone. D-Link, gone. Look at this. Some of this stuff is locked in. How did that happen? Emulex. I can't turn that off. Google devices I can turn off. Why? Wee or whatever you want to call them. No. Just say no to that trash. Intel devices. All Intel devices are gone. Microsoft, they're gone. J Micron. The last time I saw J Micron stuff was on like Ester or certain very special type of embedded boards. It shows the dependencies to turn off. Okay. Mellanox. Well, it says, oh, okay. You know what? This is too much like work already. This is turning into too much like work. I'm going to turn off as much as I can, and the things that I can't turn off, I'm just going to accept as, you know, I'm being jammed, and that's life. NVIDIA, when's the last time you saw NVIDIA networking stuff anyway? QLogic is great stuff. QLogic is fantastic stuff, but no. Do I want to put 10 gigabit on this? Hold on a second. Let me just think about the 10 gigabit. There's my Realtek. Don't touch that. I got to go back up to Intel 10 gigabit. Hold on a second. Where's the Intel stuff? Okay, right there. Intel. I need the 10 gig. I may drop a 10 gig card in that machine. Just a second. right there. Oh, it's a module. 10 gig PCI Express adapter support. And it says it's module only? Oh, Intel Pro 10 gig. Yeah. Don't you have an old config of it? No, this is a brand new. This is like, this machine's only been up and running for like 8 or 9 hours. This is a brand new machine that has never done this before. Okay, that's it. I'm exiting out of here. We can be here all day long farting around with this stuff. And I'm getting to like that point where anybody that would be watching this video would be fast forwarding and saying, is he ever gonna shut up? He keeps turning off stuff. Yeah, get out of here. Exit. Done. Alright. Let me see what else I can get away with in device drivers that I can turn off. Like really obvious crap, you know? Multimedia. Gone. Don't need it. Remote controller. Don't need it. Graphics support. I need 3258 lines. Yikes, man. Sound cards, gone. USB we need. Sony memory stick. MMCSDSCI card support. No, we don't need that. And I'm not gonna, part of me just wants to keep pecking away, you know, turn off this, turn off that. Microsoft Surface platform specific device drivers, gone. You know, we could be here all day doing this crap, all day. Let me go into file systems and get at least a couple critical things done. All right, ext2, bake it in. Just bake it right in. Besides, that's my boot file system. ext3, bake it in. Okay, just bake in the ext2, ext3, ext4 stuff. Bake it into the kernel. It's not a module. Say goodbye to Riser FS. We're not doing it. We're not doing JFS. I'm not doing XFS from Red Hat. We're not doing that. Butter. We're not going to be doing any butter. Butter FS. You want to know what's missing in this, and will be missing forever? ZFS. It'll be missing forever. You will never be able to integrate in ZFS into the Linux kernel because of the damn license called the kernel, the CDDL. I still have memories of talking with Denise Cooper. We're yakking on the phone. She's being bugged by lawyers continuously. It's not her fault. It is not her fault. No, OpenZFS, no, same license. You can't, no. It'll never happen. Out of heck with it. Let's get out of here. We could be here all day. We could be here all day. It'll never happen. It's sad but true. Sorry, kernel memory initialization. Enable heap memory zeroing on free by default. This is a nice feature. No automatics. Okay, I don't want to get into this. Nope, just get away from that. Get away from that. And get away from that. Just, okay, cryptographic API stuff, go right to the bottom. Certificates for signature checking. This is where we need to specify our kernel key. We built it. PEM, portable encrypted mail, something like that. It's kernel key. KER kernel underscore key. That's our key. Oh, is Samba in there? Really? Samba is in there? Okay. There's the module for signing. Additional X59 keys for default system stuff. Make damn sure this is in place, or you can't sign your kernel modules. Okay? Make damn sure you've got this in place. Oh, did you go look for the Sun Happy Meal, yeah, the comments in that code? Yeah. Yeah, having read through that more than a few times over the past 20 years. Yeah, there's some stuff in there. Okay, the man said Samba. S-A-M-B-A. S-M-B? No, I think what we're looking for here, search, just at the / S-M-B, SIFs, SMB direct stuff, network file systems, SMB direct support. I've got it turned off. Ooh. Oh yeah, this is gone. Samba, gone. Don't need it. Andrew file system support. We could be here all day doing this. Yeah, get out. Get out. Get out. That's it. Get out. Kernel hacking. No, we're going to get out. Out. Do you wish to save your new configuration? Yeah, gone. Samba, gone. Right? Yes, I do. Save it. Okay. These are warnings we saw earlier. This time, make menu config, black background menu config, configuration written, and we're done. Execute make to start the build. One would think we're good to go. You know? What was it Jodie Foster kept saying in that movie Contact? I'm good to go. I'm good to go. I'm good to go. No, you're not. No, you're not. We're missing some stuff, and it's going to blow up in about 60 seconds into the build process. It's going to blow up. And I'm okay with that because that's why I'm calling this the Linux kernel without a clue. It's taken 2.5 hours to get here because of a whole lot of talking and a cup of coffee and whatnot, you know. Oh yeah, it's a good movie. I'm just making fun of Jodie Foster, you know, her classic lines. And why is it they couldn't just follow the specifications? Because, you know, the engineers that handed over the concept of this spaceship were more than likely pretty substantially amazing engineers. You didn't need to go changing the design, which they did, of course, and that caused all kinds of problems. But anyway, you ready? Everybody ready? Everybody ready? You're gonna love this. You ready? Somebody say, for the love of God, I'm ready. Watch this. Okay, USR bin time, which I had to install because you don't get it by default. /USR/bin/nice, because it's nice to be nice. Nice-n 15. So I'm changing the priority to make this a friendly process. Make J4 good enough. And I'm going to send everything, I'm going to tee it up into a build. This is something that's worth looking at. Okay, I'm going to call this compile. Make J4. Okay. And now I'm going to count how long it takes for this to blow up. So this is stringing together a couple commands, of course. You know, I want to get a timestamp of how long it takes to blow up. I want it to be nice and polite and easy on the system. And we're going to do 4 parallel make tasks simultaneously if we can. And tee it all up into a log file. Okay. I don't think I'm going to be able to count to 20. Okay, let's give it a try. Here it comes. Here comes. 1, 2, 3, 5, 6, 7, 8. 7.5 seconds. We made it to 7.5 seconds, everybody, before the process failed. Include OpenSSL, blah, blah, blah. We don't have any of the OpenSSL development libraries, headers. We don't have any of that stuff. Oh, we also don't have any of the libelf stuff. Okay, so executable, linkable, loadable file format. We don't have any of that stuff. So we're missing at least 2, count them, 2 packages. 2. Yeah, I'm going to go searching for them over here on a machine that we know gets the job done. Starting with ELF. And you just know that Unix and Linux people have been deeply into like J.R. Tolkien and Dungeons and Dragons or something, because there's like dwarf debugging and there's elf and there's, you know. And there's always a wizard somewhere. Okay, let's go look for elf. Oh, libelf something 1. That's on the power machine. Okay, so we're going to need that. We're going to need that. Okay, so apt-get install this thing. It's already at the newest version. What? It's already installed. Just a second here. Let me go looking for SSL. SSL. Okay, libSSL dev. Maybe I'm missing something, you know, like common sense way. I know we're missing this. This we're missing for sure. Just a second here. I want to see what else blows up. Funny that is the only thing that comes up as missing. Hold on a second. Maybe because I ran like a make gelf.h fatal error. Libelf.h, no such file. Well, where is libelf.h? Huh? What package has libelf? Okay, I'm baffled now. Now I'm baffled. I'm effectively baffled. I'm just going to run the process again here. This will be log 2. And maybe we make it 8 seconds. Maybe we don't. I think we're going to be missing something. Yeah, we're missing this. This is absent, missing. We've got a dev package missing. Let's go find it. Get the Library of Congress. Please cut me some slack. Yeah, everything's an elf. Well, that was a mistake. What package contains that file right there? So let's go find it. I'm with you with the libelf dev. Let's give it a shot, you know? Why not, right? Could it be that easy? You gotta be kidding me. It's that easy. Why do I not see it over here? To heck with it. It is libelf dev. We should be there. We should be there now. Libelf dev, and previously was libSSL dev right there. Okay. One more time with enthusiasm. Log 3. And away we go. If you make it the first 30 seconds, it tends to go the whole bloody distance. Okay, away we go. Off it goes, building. If it goes the first 30 seconds, it tends to go the whole bloody distance. Yeah. I think we're okay. All right. Are we going to get a one-liner to compile the Linux kernel? No. That's not going to happen. A one-liner, it's not Debian actually. It's not Debian. It's a variation of Debian, which is better, in my opinion. I had a bit of a snarky moment with some Debian people recently because systemd sucks. It is a horror show. It is unbridled obfuscation, layers of confusion. It is crap. Documentation. Exactly, it's Dev 1. Yes, that is exactly what's in there. DEVUAN. Dev 1 Linux. Right there. It's worth looking into, and it's basically identical in so many ways to Debian, with the exception of banned packages. There are packages that are banned. They will not go in. Now, Chimera is what I'm running right now. That's the current stable release, is Chimera. Yeah, it's a fork of Debian without the systemd. This allows users to reclaim control over their system, especially with the entanglements and crap that systemd drags in. And it is crap. It's pure unbridled crap. Crap! In their packages page, I think they have a list of banned packages somewhere. And that's what they call it. They call them banned. And it's all the systemd crap is just never going to go in. Ever. Yeah, I know there's a link someplace. Well, I'll tell you one thing. You don't want systemd. You want to do everything you possibly can to get away from it. It's horrific. It's horrible. It's disgusting. And it's so bad. It's so bad. Let me tell you how bad systemd is. I have been sitting in front of Unix systems since the early 80s, doing programming work on Unix systems since the early 80s, and mainframe systems. And then when Linux came along, Linux systems on a multitude of architectures at various different scales of relatively small to aerospace industry, frickin' production large Unix and Linux environments for decades. And I came face to face with yet another systemd problem recently. And I could not figure out what to do to fix the mess that systemd was making for me. And that's on purpose. Systemd is designed on purpose to make it impossible for even a well-experienced user, systems administrator, to make it impossible for them to work with it. You are forced into a support and maintenance contract. It's about money, it's about obfuscation, confusion, layers of connected services, and the people involved that are behind it are with Microsoft, they are with IBM, and they're all about the money. And I don't give a damn what anybody says about, oh, it's a conspiracy. No, it's not. The actual people involved are inside Microsoft. It's crap. System D is crap. In any case, you have to read up on it yourself, find out why some of the most senior people in the Debian project got up and walked out and said, we can't allow this to happen. We cannot allow this to happen. And me, I've been using Debian since the 90s. I mean, hell, I worked directly with Ian Murdoch. I mean, I've got colossal respect for Debian Linux. Not anymore. It's becoming unusable garbage, trash. I mean, I might as well just install Windows 10, you know, and face a screen that says, please don't turn off your computer, or we will spank you. You know, that's what System D is all about. Okay. This machine is still cranking on factoring a bloody big number. I'm surprised actually it's dragging itself along like this, but Pollard row is really not good, especially if your factors are very close to the square root of the number. And for that matter, maybe Fermat 7 is prime. Does anybody know? Is Fermat 7 a prime number? I didn't check. I didn't even check. In any case, this is now going to run over here for a couple hours at least. It's going to be a couple hours. I mean, it's not a brilliant fast machine. It's not brilliant fast storage. It's just stable, you know? It's stable. Well, that's the Linux kernel being built. I think what I'll do is I'll do a follow-up to this in like 8 or 10 hours. I've been known to sleep on occasion. I might just fry up some eggs. I've had coffee. Who am I kidding? I'm not going to sleep. In any case, I'm going to follow up on this in, you know, when it finishes, and then do the modules, the installation of the modules, the installation of the kernel, and then we boot and run it. You know, that's what it's all about, right? And I'll follow up. So for now, I am calling it a night. All we know is, we know that Frank Nelson Cole was a time traveler. Had to be. Had to be a time traveler, you know? Where, oh, put that aside over there. Where did we leave him? There he is. There's Frank Nelson Cole, right there. The man who walks up to a chalkboard and does mind-bending proof of a result. He did mind-bending proof of a result, did not talk much about how he got that result. Like it says, Cole later admitted that finding the factors had taken 3 years of Sundays. It's not saying much else. The man was a time traveler. Yeah, time traveler. He came from that weird dark side of the moon, people. Okay, yeah, I'm gonna go raid my kitchen and be back in like I don't know. Whenever this thing's done later, I've been known to sleep. All right, thanks everybody. It's been a complete pleasure, especially you, Zero Day. I really appreciate the input. I really do. Thanks everybody. All right, yeah.